We want to know the sum of 1 over d1 plus 1 over d2 up to 1 over dk. This is our goal. I'll give you a little background of this problem. It's given that n is any number, any positive integer, and d1, d2 up to dk are the divisors of n. So divisors, positive divisors. Okay, so this list of divisors includes 1 and n, because of course 1 and n are also divisors of n. It's also given, there's one more information that's given, that's d1 plus d2 up to dk. This is 72. Now this goal becomes a little bit more clear. We want to find out the sum of 1 over d1 plus 1 over d2 up to 1 over dk. Well, with both of these information, this is given info. You can pause the video here and give this a try. It's a very beautiful problem from elementary number theory. Okay, now how do we go about this? The key idea is very simple, but it's very fundamental. It's known as pairing. I'll tell you what it is with an example. So let's take a particular example. We can pair up the divisors of a number. How can we do that? Well, let's take the number 20 and let's take one divisor of 20, which is 4. So choose 4, and now look at 20 by 4, this number. This is 5, right? So 5 is also a divisor of 20. This is a very simple thing with a far-reaching consequence. So 4 and 5, we can think of these two numbers as pair. They are somehow linked by this particular relation. One of them is the number by the other one. So this is true for any number n. So for any number n, if d is a divisor, then n over d is also a divisor. This notion of pairing, often known as duality, we can call this thing duality. This idea crops up in different parts of mathematics. For example, it's also there in geometry. You can think about it. I'll make a claim here and you can tell me why this claim is true. A cube, which looks like this, and an octahedron. So an octahedron, which looks like a diamond, like this. My claim is that these two objects are dual to each other. They're in some way pairs of geometric objects, just like d and n over d are pairs of numbers, pairs of integers. So this notion of duality is very fundamental to mathematics itself, and we will use that to solve this problem. How can we do that? Okay, what we will do is this. Let's take the numbers d1, d2 up to dk. These are the divisors of n, that's given. Now we take the pairs, so n by d1, n by d2 up to n by dk. Notice that this row of numbers is just the first row written in the reverse order. Why do I say that? Well, take the example again, 20. So the divisors of 20 are 1, 2, 4, 5, 10 and 20. And if you take the pairs, and it will be 20 by 1, 20 by 2, 20 by 4, 20 by 5, 20 by 10, and 20 by 20. Notice that these are just the first row of numbers in the reverse order, right? So what we can do now is we can add these up. Since the second row is the same numbers in the reverse order, the sum is also 72, because it's given that the sum of the divisors is 72. And now you can easily see that you can take n common and get the final answer as 72 over n. So this quantity right here, this is 72 over n. Okay, so think about why cube and octahedron are dual geometric objects. In fact, this duality is not only in divisors, it's also in the domain of coprime numbers. That's another place where duality comes up. It's a beautiful idea which runs through many parts of mathematics. Alright, so keep on doing great mathematics. I'll see you in the next one.